Good morning, dear students. Today, I would like to present three topics. First one, mass and weight. Second one, weight of an object on the moon. And third one is related numerical. For today's class, at first, I focus on how to differentiate between mass and weight. You know that all the substances in universe have matters contained in them, and the amount of the matters present in them do not change wherever they locate their place in any part of universe. What is called the total amount of matters of which a substance is made up? It is called mass. Then, mass of an object is total amount or quantity of matter of which it is made up. You studied that it is the measure of inertia of the object, which means that greater the mass, the greater is the inertia. It is constant throughout the universe. It remains the same whether the object is on the earth, the moon, or even in outer space. Then what is weight of an object? It is just amount of gravitational force acted on an object due to the earth. Weight of an object keeps changing as value of its g changes, since weight W is equal to gravitational force F, which is equal to mg. Weight of an object on the moon is 1 by 6 times its weight on the earth. At a given place, the weights of objects are directly proportional to their masses. Let us consider an object of mass small letter m located on surface of the earth of mass capital letter M of radius small letter r. Let g be its acceleration due to gravity at the earth's surface. Then weight of the object Fg is equal to g capital letter M small letter m divided by r square, which is equal to mg. Since gm divided by r square is equal to g, you know that acceleration due to gravity of different objects at a given place are same, but their weights are different as their masses are different. It means that greater the mass, greater is the weight. So, weights of objects are directly proportional to their masses at a given place. By recollecting these all points I told, you are now able to distinguish between mass and weight. First point is, mass is the quantity of matter in a body, but weight is the force by which the earth attracts towards its center. Second point is, mass is a scalar quantity, but weight is a vector quantity and is always directed towards the center of the earth. Third point is, mass of a body is always constant everywhere in the universe, but weight of a body varies from place to place and becomes to zero on the center of the earth. Fourth point is, mass of a body is m is equal to F by g or F by a, but weight of a body W is equal to mg. Fifth point is, mass can be determined by ordinary balance, but weight of a body can be determined by spring balance. And sixth point is, unit of mass in SI system is kilogram, but unit of weight in SI system is Newton. And you have to know that 1 kilogram weight is equal to 9.8 Newton. How did it convert from kilogram weight into Newton? 1 kilogram weight means weight of a body of its mass 1 kg. Since W is equal to mg, then it will be equal to 1 kg into 9.8 meter per second square. It will be equal to 9.8 Newton since 1 Newton is equal to 1 kilogram meter per second square. You understood that weight of a body is equal to 0 at the center of the earth when g is equal to 0 at this location. You learn that value of g keeps changing due to the variation of radius of the earth. Because of the earth is not a perfect sphere. You know that the earth is flattened at its pole and bulged at its equator. It shows that G is maximum at polar region and minimum at equatorial region as G is equal to capital letter G me divided by r square. As mass of an object is constant even at any location, weight of the body varies with respect to G since W is equal to mg. So weight of the object is maximum at polar region and minimum at equatorial region. Next, I am going to discuss on the method of calculating weight of an object on the moon. We have G is equal to Gm divided by r square and W is equal to mg. So weight of a body of mass small letter m on surface of the earth is given by We is equal to mge, which is equal to mgme divided by r square. This is the expression number 1. Since Ge is equal to Gme divided by r square, where Ge be the acceleration due to gravity of the body on surface of the earth, me be the mass of the earth and reb is radius. Then weight of the same body on moon is given by Wm is equal to mgm, which is equal to mgmm divided by rm square. This is the expression number 2 since Gm is equal to Gmm divided by Rm square, where Gm be the acceleration due to gravity of the body on the moon, mm be the mass of the moon and Rm be its radius. We know that mass of moon mm is 1 by 100 times the mass of the earth me and its radius Rm is 1 by 4 times the radius of the earth Re. So Wm divided by We is equal to mm divided by me into Re divided by Rm the whole square, which is equal to 1 by 100 into 4 square is equal to 1 by 6. Here we have seen that weight of a body on surface of the moon is 1 by 6 part of its weight on surface of the earth. It means that the moon's gravity only 1 by 6 as strong as the earth's gravity. Suppose a man has mass 120 kg, then his weight will be equal to mass into acceleration due to gravity. Here G is taken as 10 meter per second square, then his weight will be equal to 1200 Newton. When the same person is on the moon, what should be his weight? It will be equal to 1 by 6 of his weight on the earth is equal to 1 by 6 of 1200 Newton is equal to 200 Newton. It is important to know the values of the following quantities. Mass of the earth is equal to 5.972 into 10 the power of 24 kg. Its approximate value is equal to 6.0 into 10 the power of 24 kg, and acceleration due to gravity on surface of the earth is equal to 9.8 meter per second square, and mass of the moon is equal to 7.348 into 10 the power of 22 kg, and its approximate value is equal to 7.3 into 10 the power of 22 kg, and acceleration due to gravity on surface of the moon is equal to 1.6 meter per second square. At least it has to remember the approximate values. What should be the expression of acceleration due to gravity of the moon, which could be expressed as G moon is equal to capital letter G into M moon divided by square of D moon, where M moon be the mass of the moon and D moon be the radius of the moon. Can you answer the question, how can you differentiate between universal gravitational constant capital letter G and acceleration due to gravity small letter g? The table given below shows the differences between acceleration due to gravity small letter g and universal gravitational constant capital letter G. The first point is symbol. Acceleration due to gravity is represented by small letter g, and universal gravitational constant is represented by capital letter G. Second point is definition. The acceleration due to gravity is the acceleration experienced by a body under free fall due to the gravitational force of the massive body. But universal gravitational constant is the force of attraction between two objects with unit mass separated by unit distance at any part of this universe. Third point is nature of value. Acceleration due to gravity changes from place to place. Its value on the surface of the earth is equal to 9.8 meter per second square. But universal gravitational constant, which is always constant, that is at any point in this universe it is constant. Its value is equal to 6.673 into 10 the power of minus 11 Newton meter square per kilogram square. And fourth point is unit. SI unit of acceleration due to gravity is meter per second square, and SI unit of universal gravitational constant is Newton meter square per kilogram square. From given slide, mass of an object is given as 10 kg. Then what should be its weight on the earth? It will be equal to mg is equal to 10 kg into 9.8 meter per second square is equal to 98 Newton. Can you say what should be its weight on the surface of the moon? It will be equal to 1 by 6 into weight on the earth is equal to 1 by 6 into 98 Newton. That will be equal to 16.33 Newton. Let us see how to solve given numerical. First question is, an object weighs 10 Newton when measured on the surface of the earth. What should be its weight when measured on the surface of the moon? See the solution. Given that weight of the object measured from the surface of the earth is equal to 10 Newton. You know that acceleration due to gravity on the surface of the moon is equal to 1 by 6 times to that at the earth. So weight on moon is equal to Wm is equal to 1 by 6 into We is equal to 1 by 6 into 10 Newton, which is equal to 1.67 Newton. And second question is, gravitational force on the surface of the moon is only 1 by 6 as strong as gravitational force on the earth. What is the weight in Newton of an object of mass 100 kg on the moon and on the earth? What should be its solution? We know that acceleration due to Earth's gravity Ge is equal to 9.8 meter per second square. Here, given that mass of the object m is equal to 100 kg. Let Gm be acceleration due to moon's gravity. Let We be weight of the object on the earth, and let Wm be its weight on the moon. We know that weight of the object is equal to mass into acceleration due to gravity. And also it has given that Gm is equal to 1 by 6 into Ge. So Wm is equal to m into Gm is equal to m into 1 by 6 of Ge, which is equal to 100 into 1 by 6 into 9.8, which is equal to 163.4 Newton. And We is equal to m into Ge is equal to 100 into 9.8 is equal to 980 Newton. Here we have found that weight of the object on the moon is equal to 163.4 Newton and weight on the earth is equal to 980 Newton. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.